So I'm going to do a quick demo. We're going to start with the delineation map with an overview of where our BMPs are in our landscape. And I'm gonna tunnel into a couple of BMP detail pages. We can look and see how their delineations are defined, what parameters were required, and how those results are shown. But I'm not going to be demoing all of the capabilities of Orange County Stormwater tools. And if there's a feature functionality that was described previously in the presentation that you're hoping to see that we don't get to today, don't forget to contact us, because we can show you each of these pieces. So anyway, let's get started. So I've got up on my screen here the delineation overview map in the inventory module. This is a top level view of all of the facilities in South Orange County, and it shows us how our BMPs are related to the landscape and to each other. So I'm going to zoom in here on a centralized facility, and I'll toggle on those regional subbasins that I mentioned that show us our neighborhood scale. This layer in the black line is managed by OC Survey, and recall that these layers point to the next downstream feature. So a centralized BMP situated down here at the bottom of this watershed will treat one or more of these upstream BMPs. And so the centralized delineation is shown in purple for this BMP down here. And these blue BMPs are distributed BMPs. They treat just the adjacent upstream land surface. So let's go look at this one's a vegetated swale BMP. We can see that the user has delineated a region here, a neighborhood street, and the position of the BMP is down here. We've got 3 or so acres and a land use breakdown, predominantly residential and some local road. For this BMP, we actually needed a few more input parameters. I think 4 of these are required: the treatment rate of the BMP, the area, the effective retention depth, and an underlying soil group to get some infiltration here. Now, every half hour, as I said, the system, if this has changed, will recompute it and report our performance here at the bottom. So right now I've toggled on the wet weather results. So this BMP in stormwater conditions are getting 70% retention. It's pretty good, and is treating and discharging 17% here. So we can see our pollutants of concern are being reduced, and our volume is being treated in wet conditions. The dry conditions with this relatively small upstream area and relatively large BMP means we're capturing and able to retain 100% of our dry weather inflow in this case, which means that as a fraction of our influent loading, we're getting 100% reduction because we're not discharging. And overall, this BMP is doing quite well. We can report this performance on a high level for both dry weather and wet weather conditions. But distributed BMPs aren't the only ones supported in our system, and we've got the ability to treat land areas that are quite a lot larger. And with a centralized BMP, we can take advantage of the fact that there are upstream BMPs, right? And we can get these BMPs to be nested within each other's delineation. So this is the delineation for a low flow diversion situated at the bottom of this sort of watershed, and it's treating 1,300 or so acres with a good mix of land uses. And so a low flow diversion is going to be operated in the summertime to divert dry weather flows to a water treatment facility. So when we look at these results, we expect the performance to be quite good during dry weather. It's sized for the dry weather flow rate, so it's reducing the dry weather flows, and it's not really performing in wet weather. Often these systems are toggled off for wet weather, and they'll bypass during stormwater conditions. We can then, of course, summarize these types of BMPs quite easily. And again, centralized BMPs, the influent to centralized BMPs is already accounting for the effect of upstream BMPs. So our solutions here are nested and our benefits accumulate. So with that, I would turn it back over to the slideshow.